All right, this is Unit 7, Lesson 2. The lesson is called Factoring Polynomials. Now, a long time ago, I believe it was Unit 3, we did factoring quadratics. Now we're going to be doing factoring polynomials, so higher degree than 2. Sometimes. Sometimes it'll be higher degree than 2, sometimes it might not be. Okay, so we're going to recall the following. The difference of two squares. We did that in Unit 3. You factor that like this, a squared minus b squared equals a minus b. I mean, a plus b I'll do first. A plus b times a minus b. Factoring the sum of two cubes. We did that in the last lesson. A cubed plus b cubed equals a plus b times a squared minus ab plus b squared. And then factoring the difference of two cubes, that's a cubed minus b cubed equals a minus b times a squared plus ab plus b squared. Okay. Example 1, factor x cubed minus x squared minus 25x plus 25 completely. Okay. So your first step is always check to see if there's a GCF between all the terms. And this one, there is none. So what we're going to do is we're going to do factoring by grouping. Okay. I'm going to group the first two terms together because I know they have a common factor. And we'll take up the common factor of x squared. So when I take out the common factor of x squared from the first group, it leaves me with x minus 1. Because x squared times x is x cubed, and x squared times negative 1 is negative x squared. I'm going to group these two terms together, and I'll take out the common factor of those two terms. And I'm actually going to take out a negative 25. I'll explain why in a minute. But when I take out a negative 25, it leaves me with x minus 1 in parentheses. Because negative 25 times x is negative 25x, and negative 25 times negative 1 is 25. Suppose you accidentally took out a positive 25 for your GCF. That would leave you with negative x plus 1 in parentheses, which does not match those parentheses. You want the parentheses to match. Okay, and now if you remember back to Unit 3, the parentheses match, so I'll factor that out to the beginning. Everything left over comes in the second set of parentheses. In this case, what's left over is x squared minus 25. And now you're not done because now you have the difference of two squares right here. Okay, now we have the difference of two squares. So sometimes you might have to factor more than once. Now you have to factor this. I gave you that rule above, a plus b times a minus b. Okay. Again, the reason why this is the difference of two squares is because x squared is a perfect square. It equals x times x. And 25 is a perfect square. It equals 5 times 5. So I'm going to factor that down to x plus 5 times x minus 5. Example 2, factor completely. We're going to do factoring by grouping again. We've done that before. We've done that in Unit 3. Now we're doing it with a higher degree than 2 on the exponents. Okay, that's the only difference here. Is now we're doing them with higher degrees. Whereas Unit 3, we just did degree 2, quadratics. Now we have a higher degree than 2. So for my first group, I'll group these two together. I'll take out the GCF of x squared. So that's going to leave me with x minus 2 in parentheses, because x squared times x is x cubed, and x squared times negative 2 is negative 2x squared. For my second group, I'll take out a GCF of negative 9, which will leave me with x minus 2 in parentheses. because negative 9 times x is negative 9x, and negative 9 times negative 2 is 18. Now my parentheses match, so I'll factor that out to the beginning. X minus 2 comes out to the beginning. And what's left over in parentheses will be x squared minus 9. And again, you don't always get the difference of two squares here, but now we do, okay? Since x squared can be thought of as x times x, and since 9 can be thought of as 3 times 3, it means I have the difference of two squares. That does not always happen, but it happened in example 1 and example 2. So I'm going to factor x squared minus 9 down to x plus 3 times x minus 3. And again, I gave you that rule above, but we did that earlier in the year. So hopefully you remember that. That's how you factor example 2. Example 3, factor 81x to the fourth minus 625 completely. Now this one is actually the difference of two squares, because 81x to the fourth, that can be thought of as, let me do this in a different color. That can be thought of as 9x squared times 9x squared. And 625 is a perfect square. Okay, the square root of 625 equals 25. So we actually have the difference of two squares. So this is going to factor to become 9x squared plus 25 times 9x squared minus 25. What's the only thing better than doing the difference of two squares once? Doing the difference of two squares twice, okay? Because this is also the difference of two squares. Because 9x squared is 3x times 3x, and 25 is 5 times 5. There is no factoring for the sum of two squares, so that's going to stay alone. That's going to stay as is. But you're going to factor this down more because this is the difference of two squares. So for my final answer, I have 9x squared plus 25 times 3x plus 5 times 3x minus 5. Example 4, factor x to the fourth plus 10x squared plus 21 completely. Now, there's two ways to think about this problem, so let's do it each way. First, I'll do whatever number is before x to the fourth. In this case, it's a 1. If you do 1 times 21, that equals 21. You're looking for numbers that multiply to 21 and add to 10, okay? You need numbers that multiply to 21 and add to 10. Let me get a piece of paper. So let me just write that out. We need two numbers they have to multiply to 21. You have to add to 10. So the numbers that you want are going to be 7 and 3. So what I'm going to do is I'm going to rewrite the middle term, 10x squared. I'm going to rewrite that as plus 7x squared plus 3x squared. Okay, so I took that 10x squared, the middle term, I took the middle term and I replaced it with these two numbers. And I added x squared to each. Now it's just like the first page, factoring by grouping. Let's group the first two terms together. I'm going to take out the GCF of x squared When I take out the GCF of this group of x squared, I get x squared plus 7 because x squared times x squared is x to the 4th, and x squared times 7 is 7x squared. For my second group, I'll take out the GCF of 3. And it's going to leave me with, in parentheses, x squared plus 7, because 3 times x squared is 3x squared, and 3 times 7 is 21. Now, take out the parentheses match. That comes out to the front. X squared plus 7 comes to the front. And everything left over, in this case, x squared plus 3, comes in the second set of parentheses. The other way to do this one is, since it's 1x to the 4th power, think about it like this. Think about if it was x squared plus 10x plus 21. If it was x squared plus 10x plus 21, you would just factor that to x plus 7 times x plus 3, which is the same thing we have here, but it's x squared and x squared. Okay? Again, that's good to think of if it's 1x squared and 1x to the 4th power. You think about it like that? Okay, example 5. Kind of like example 4. Okay. You're going to do 1 times negative 40. That's negative 40. So you need two numbers. You have to multiply. 1 times negative 40 is negative 40. So you have to multiply to negative 40. You have to add to the 3 in the middle. So pause the video if you need to think about those numbers. But they're going to be 8 and negative 5. So those are the numbers you want. You're going to replace the middle term with those two numbers. So I'm going to write x to the 4th power plus 8x squared minus 5x squared minus 40. Those are the two numbers we got. Now I'm going to do factoring by grouping. I'll group the first two terms together, and I'll take out the GCF of x squared. So it leaves me with x squared plus 8 in parentheses. And I'll take out a negative 5 from the second group, which will leave me with x squared plus 8 in parentheses. Because negative 5 times x squared is negative 5x squared, and negative 5 times 8 is negative 40. Now the parentheses match, factor that out at the beginning. Everything else, in this case, x squared minus 5 comes in the second set of parentheses. And also be careful, check to see if that's the difference of two squares, because you might have to factor more. So if that was x squared minus 9, you would factor more, because 9 is a perfect square. If that was x squared minus 25, you'd have to factor more, because 25 is a perfect square. This one you don't have to factor more, though, so that's the answer. And again, another way to do this is think about it. Think about, suppose it was x squared plus 3x minus 40. You would factor that down to x plus 8 times x minus 5, which is the same thing we got here, but now we have squared and squared. Okay. This next one, a little trickier. First thing you're going to do is, if you think about, it's kind of like when we did 3x squared minus 19x minus 14. First thing you're going to do is you're going to do 3 times negative 14. So in example 5 and example 4, you did not have to do this because it was 1x to the 4th power. 1x to the 4th power. But this one's not 1x to the 4th power. So first you're going to do 3 times negative 14. That equals negative 42. Now you need two numbers. those numbers must multiply to the aforementioned negative 42. They have to add to the negative 19 in the middle. So think about what those numbers are. It's going to be negative 21 and 2. So what I do is I'm going to replace the middle term with those two numbers, like this. So I'll do 3x to the fourth power. Instead of negative 19x squared, I'm going to use these two numbers. So I'll do minus 21x squared plus 2x squared, and then minus 14. And now it's factoring by grouping like we've been doing a lot today. The first group has a GCF of 3x squared. So that leaves me with x squared minus 7 in parentheses, because 3x squared times x squared is 3x to the fourth. And 3x squared times negative 7 is negative 21x squared. The second group has a GCF of 2. Factor that out, and it leaves me with x squared minus 7 in parentheses, because 2 times x squared is 2x squared, and 2 times negative 7 is negative 14. Now the parentheses match, so factor that out to the beginning. X squared minus 7 comes out to the beginning, and everything left over comes in the second set of parentheses, in this case 3x squared plus 2. Check to make sure that's not the difference of two squares, and it's not, so this is my final answer. And also, don't forget to always check for GCF in the beginning of each problem. Okay, so again, a lot of that lesson involved stuff we've done early in the year. There was really nothing new in this lesson other than the fact that we were doing it with higher degree polynomials. In the beginning of the year, we just did quadratics, which was degree 2. And as you can see, this lesson had degree 3s and degree 4s. That's the end of that lesson. Unit 7, lesson 2, factoring polynomials.